This is a chromium. Okay, this is the electronic configuration of chromium: 1s2, 2s2, 2p6, 3s2, 3p6. This is the total here 18, and 3d5. This is the 23. This is the total 24. So here will be 1. So why didn't I write 4s2 and here 3d5, 3d4? Why didn't I write 4 3d here 3d4 and 3d4 and 4s2? Why didn't I write? Do you know? Why didn't I write this way? This is also this is 18 and this 6 24. Why didn't I write this way? I write 3d5 and here in s orbital I write 1 electron. This is the exception for chromium, because orbital half filled and full filled are stable. Half filled and full filled orbitals শব্দ করে না গো, 4p orbital are more stable. Okay, this is the 4 stable. Half filled and full filled orbitals are more stable. So which is the, if I write 3d d orbital, how many electron d orbital can occupy? Total highest electron d orbital can occupy how many electron? S orbital can occupy highest 2 electrons, p orbital 6 electron, d orbital 10. Okay, this is the half filled. D5 is a half and D10 is full. This the D10 and D5 is a half filled orbital and full filled orbital are more stable. So here electron orbital all element want to become stable. So this electron here not going to 4s2 becoming, it become 3d5 half filled and it is also half filled. So 3d half filled so more stable. So it to become stability, to gain more stability, it become half filled. Half filled orbital are more stable. For these reasons this is 3d5. Have you understood?
Yes, sir.
Okay, this is like this is a copper electronic configuration is same. You don't need to write 3d10 and 4s1. You write don't need to write 3d8 and 4s2. Okay, now I will not say this. I didn't see this electronic configuration. Now I am not watching. Have you understood what I said? Just didn't understand. I didn't write electronic configuration of chromium, so I not explain these things. Okay, and now I am explaining chromium. Okay, there is also exception here is copper electronic configuration. Look, this here also use half filled and full filled. And now you can draw these things. What will be a Hund's rule electronic configuration using 1s orbital, then 2s orbital, then 2p orbital, 3 2p orbital, 3 2p orbital, then 3s orbital, then 3p6 orbital, 3p6 orbital, and then 5d orbital. D orbital there are 5 electrons, 5 orbitals, 5 orbitals. Then s orbital. This is 1s this is 2s, this is 2p, 2px, 2py, 2pz, you can write here 2p, then 3s, 3p, 3d, and 4s. Okay, how many electrons here? 2 electrons. These 2 electrons. So 2p orbital. I'll at first have singly, yeah, this narrow space. At first you this 6 electron, this 3, then 4, 5, 6, this 2 electron. Here also 6 electron, 3p. You write this 1, 1, 1, then 4, 5, 6. Okay, this is the 3d 5. This is 1, 2, 3, 4, 5. Okay, and this is the last is 4s1. 1s. Okay, have you understood your chromium electronic configuration? This is the chromium. Okay, using Hund's rule. You didn't write these things. You got 24 out of 25. Okay, have you understood these things?
Yes, sir.
Okay, now to rest topics. Okay, now this sodium, how many electron? What is the electron here? Sodium, you know, we write this way: first shell 2 electron, second shell 8 electron, and outermost shell electron 1. Okay, this is how many electron in the outermost shell? This is the electron. Okay, the energy required to remove 1 electron of an atom of an element in the gaseous state is called ionization energy. What is called? From the outermost shell, the energy required to remove 1 electron from the from an atom of an element in the gaseous state is called ionization energy. Like sodium is if the sodium must be gaseous state. Sodium, you know, solid. It will be when it remove 1 electron. To remove 1 electron, the amount of energy is required is called ionization energy. So it become 1 positive charge. Why this is become 1 positive charge? Why this is become 1 positive charge? Because sodium, how many electron? This sodium atom, do you know how many electron? I have written already 11 electron.
Electron.
So how many proton? How many proton? Don't know, no? 11 proton. Because in an atom, this is the atom is electrically neutral. Number of electron and proton are same. So 1 electron. If it is lost 1 electron, then it become 10 electron when ion, but proton numbers remain same. When become ion, 10 electrons. So here positive is more. Positive is 10 proton positive and a negative 10 electrons. So positive 1 positive, more 1 positive. So 1 positive. Okay, for this reason. Okay, when electron, 1 electron is removed from an atom. From when electron is removed from an atom of an element in the gaseous state is called also fast ionization energy. Is called fast ionization energy. Okay, so I am going to here this topics is ionization energy. Should write here. Ionization energy. So what is ionization energy?
The energy required
Eh?
to remove
An electron
an electron from an element.
from an atom of an element
From an atom of an element.
in the gaseous state. In the must
In the gaseous system.
in the gaseous system must be said. So it is called ionization energy. Okay, next is first ionization energy. Ionization energy and first ionization energy definition is same. Now I am going to this magnesium. Do you know magnesium how many electrons? Aluminium. Aluminium. How many electrons?
13.
13 electrons. This. If I remove one electron, it become
12.
Aluminium plus. Okay. Okay. This thing can be written. Wait. What? Okay, this minus left hand side minus I can write here in the right hand side. This minus become plus. This can be right plus in the right hand side. If I write this negative electron and minus in the left hand side, it write this is right hand side. In the left hand side negative and right hand side it become positive. Okay, this is called, what is called? It is first ionization energy or second ionization energy or third ionization energy?
First.
Yes, first ionization energy. Okay, this is the first ionization energy. First ionization energy. Okay, this is can be represent. Okay, now if I removed another electron from this charge, from one positively charged gaseous atom, one positively charged gaseous atom, one positively charged atom of an element in the gaseous state is called second ionization energy. So it will be remove this from one positively charged atom. If I remove one electron, then it become how many positive charge? Two positive charge becomes, and this is the two positive charge, and this the two electrons. One electron here. I have to write again. One electron. Okay. So this is called second ionization energy.
Second ionization energy.
Second ionization energy. Okay. Okay, if I remove the one electron from an two doubly positively charged gaseous atom, is called third ionization energy. Okay, I am writing these things third ionization energy. Like this is three positive charges, two positive charges. It must be two positive charges. If I remove another electrons, and this is now it becomes 3 plus positive. So one electron here, negative electrons. Okay, this is the third ionization energy. Okay, third ionization energy. Third ionization energy. Okay, তার ionization energy. Okay. um, so I am giving a question, you write his equation. I not write these things. Okay, have I questioned this one? Okay, I'm giving a question, you write this thing. Write the, it is imaginary element, symbol like m. Question 1. Write the equation of second ionization energy. Write the equation for second ionization energy of an element x, x na m দিয়ে দে. Okay, right, this is your what is this? Oh, this is not my topic. It is AS class student given here. It is buffering this slow network. I think it is doing in all over the Bangladesh except the official prime minister. Have you visited abroad? You came from India, no? Have you? No.
No, sir. Qatar.
Qatar, that means Middle East. What is this? I'm not able to watching this. Okay, I am watching from my. Yes, correct. Excellent. Excellent. I have this checked. Okay, done well. Though the Ogo Ma, you know the reaction is two types depend on energy, exothermic and endothermic. Do you know?
Yes, sir.
Okay, what is exothermic reaction? You know this reaction, your house is cooking, during the cooking at house, natural gas burning energy is released to the surrounding. This surrounding becomes hot. This is the exothermic reaction. And in some reaction it's like you add a water in glucose added, the reaction medium become cool. You maybe observe these things. This reaction is when energy gained, it is called energy gained or required is called endothermic. Okay, so it is endothermic reaction. Exothermic reaction, the reaction in which energy is released to the surrounding, is called exothermic reaction. Or endothermic reaction, the reaction in which energy is gained from the surroundings is required, is called endothermic reaction. Endothermic and exothermic, you know. Endothermic reaction ki energy Energy released or gained?
Released.
Energy released. And no, endo energy required or gained. Energy
Gain.
required or gained. এটা কেটে দেই energy required energy resist. Okay, so this why this ionization energy is endothermic? Can you say why ionization energy is endothermic? Can you say why ionization energy is endothermic? That why ionization energy is that ionization energy is endothermic. Okay, do you know? Okay, because here in this reaction, do you know why ionization energy is endothermic?
Because ionization energy is required to remove.
Yes, okay, energy is required, always energy is required to remove electron. Energy is for these reasons. Okay, this is given here. I wrote shit. Ionization energy has positive values because energy is always required to remove an electrons. It is endothermic. Electrons are attracted to the nucleus, therefore energy is needed to remove them. Okay, ionization energy depends on three factors. Ionization energy depends on three factors. Do you know what are the three factors? Orbital in which nuclear charge of the atom, like number of protons in the nucleus, the orbital in which electron exist, the electron repulsion, shielding effect. How many factor depends? Ionization energy depends on how many factors? I have just said how many factors? Three factors. What are the names? Nuclear positive charge of an atom and orbital exist, and another is electron repulsion, shielding effect. Okay, I am writing here these things. No, I will not write here. Is given. What is this? You know? Oh, I told already. So you think these things positive charge. Ionization energy depends on what is this? Inaliza. আমার নেটওয়ার্কে আজকে প্রবলেম করতেছে আজকে কিন্তু কারেন্ট ও বাসার মধ্যে কারেন্ট ওর অবস্থা ভালো না electricity gone already 3 times are you listening me hello student are you listening me three factors: number of protons in the nucleus or the nuclear charge of the atom. And second is the electron repulsion. Electron repulsion of inner shells. Electron repulsion. This is called shielding. This is called shielding. Shielding. Do you know this? What do you mean shielding means? Shielding. Yes. Shield means it is protecting in a war some chest in the ancient time wars during the when the horse used warriors use helmet something to protect their head, and body chest from attack from knives attacks. So this is called shield protection. Like it is the shielding, like this way. Shielding a screen. Shielding is also known as screening. Okay, shielding. Electron repulsion and shielding or screening effect. And next is 3 number is 3 is subshell from orbitals. Orbitals another names or subshells. We know orbitals are subshells. Subshell from which electron is removed. Orbitals or subshell from which electrons is removed. Okay, if the nuclear charge increases, ionization not increases. If the shielding effect is not maybe clear, like electron repulsion in the inner shell. Like I am right, lithium. Lithium, how many electron? Lithium and sodium. Lithium and sodium. Are you watching my screen?
Yes, sir.
Okay, lithium, how many electron? And sodium? 3.
7. Not 7. 11.
11. This is 3. Okay, for lithium is that 3. Lithium 3. Okay, this is group 1 element, both 2. Okay, this lithium 3 electrons. Okay, this is 3 electron. Sodium 8 electron. 2 electron is first shell, 8 electron in the second shell, and 1 electron in the third shell. So here shielding effect, electron repulsion. Shielding effect here, the electrons from the nucleus and electrons. Electron repulsion here. The inner shell increases. Look, here is a one more inner shell. In the outer electron, and shell is more, one shell. Here is a 2 shell. Here is a 3 shell. So one more inner shell here, shell. So electron repulsion shielding effect, electron repulsion. Okay, here due to electron here more electron, so electron repulsion is more, so shielding effect is more. If shielding effect increases, ionization energy decreases because electron can be removed easily. Here less shielding effect, so attraction is more because I am again explaining there is a inner shell, also electron contained in this, so electron repulsion increases. Repulsion increases means, so repulsion increases, so attraction between positive charge and positive nucleus and electron, positive charge and electron decreases. Repulsion হইলে কি হবে? Repulsion, due to repulsion attraction decreases. Due to electron inner shell, so repulsion increases, so attraction decreases, positive nucleus and electron, so electron can be easily removed. More electron shell, inner shell with shielding effect increases. So shielding effect, shielding or screening, screening, or here ionization energy, ionization energy, that কি হইলো? আচ্ছা, শিল্ডিং অর স্ক্রিনিং এটা এখানে নেই। Here shielding কি? That shielding, more ionization energy, more shielding, less ionization energy. Have you understood this?
Yes, sir.
Shielding. Okay. So in a group, in a group, ionization energy down a group from top to bottom, ionization energy increase or decreases? In a group, you know this, CGM francium. Okay, this is group. Ionization energy increase or decreases from top to bottom? Increase. No, from top to bottom ionization energy increase or decrease. You didn't understand maybe. Look this, down in a group, shielding effect increases, like it is 2 shell, here is a 3 shell, for lithium 2 shells, sodium 3 shell inner shell, this potassium 4, like this is shell increases. So down a group, shell increases means electron repulsion increases, that means shielding effect increases. So shielding effect increases, so that means ionization energy decreases. Shielding effect means protection increases. Protection increase করলে না, protection increase করলে তো উল্টা বলতেছি নাকি আমি কি বলতেছি, শিল্ডিং এফেক্ট এই গ্রুপে কি কমে যায়? Okay, shielding effect. Shielding effect, it decreases as screening increases. দেখিস না এটা কি দেখছি, here is it given sheet. Mm, that okay, the outermost electron is screened or shielded from the attraction of the nucleus by the repelling effect of the inner electrons. As shielding increases, the attraction of positive nucleus and negative electrons decreases, so less energy is required to remove an electron. Okay, as shielding increases, the attraction of positive nucleus and negative electrons decreases. Shielding F increases as result attraction of positive nucleus. Shielding means repulsion. Repulsion, not repulsion, not attraction, not. So attraction decreases. Shielding means repulsion, electron repulsion. As shielding increases means electron repulsion increases. So the positive nucleus and electron attraction decreases. So less energy is required to remove an electron. That means ionization energy decreases in a group, maybe. Or in a group. Okay, here look. Ionization energy. That it a cup second. Okay, now size of the positive nuclear charge. As the nuclear charge increases, the attraction of outermost electron increases. So more energy is required to remove an electron. That means ionization energy increases. When size of the positive charge increases, that positive charge increases. Positive charge increases means attraction of positive electrons and positive charge increases. So more attraction means more energy is required to remove electron. That means when charge of the ions increases in a group in a same period, when charge increases, ionization energy increases. Can you say group 1, group 3 period elements, 2 period elements like okay, sodium and magnesium. Which one has more ionization energy? Sodium and magnesium? Sodium? No. Magnesium or koto? Can't, because why this is magnesium is more ionization energy? Because why? This is one positive charge, this two positive charge, because shell number is remains same, but charge is increases. Positive charge is increases, more positive charge, more nuclear charge is more. So attraction between positive nucleus and electron is more. So more electron is energy is required to remove electron. So now I am checking these things. Which one is more energy, ionization energy? Between sodium and magnesium. is not given here. Ionization energy of period 3 elements, period 3 elements, period 2 elements. Okay, the period 2 elements को देखें. दूध तरी इमेज देखें. Okay, look, this is the sodium and magnesium. Are you watching these things? Which one is more ionization energy? Sodium and magnesium. Are you watching clearly?
Yes, I'm watching, sir.
So which one is more ionization energy? Sodium and magnesium? Magnesium, this thing. Magnesium is more ionization. Again, ionization energy for aluminum is decreases, and the silicon increases, phosphor increases, for sulfur decreases, chlorine. So what happens this here? Why aluminum ionization energy decreases? Okay, look, this is it is due to the orbital effect. I have said these things. Also, orbital of subshell from which electron is removed, it is also responsible. It is between magnesium and aluminum. Which one is more ionization energy? Magnesium, but it is conventionally aluminum should become, but why magnesium? Because look, magnesium electronic configuration, magnesium 12, 1s2, 2s2, 2p, 6, 3s2. This is the magnesium. And for aluminum, 13. This is the 1s2, 1s2, 2s2, 2p, 6, 3s2, and 3p1. Here the outermost shell electron is full filled, orbital is full filled, so this is the more stable. Full filled, it is not full filled or half filled, p orbitals. It is not full filled or half filled, so it is less stable, more stable for this reason. Have you understood? For this reason, magnesium is more full orbital, filled. Okay. So it is this effect, orbitals or subshells from which electron is removed. Number of protons in the nucleus. This explanation. This is two factors is here responsible. Here factor number 3 is responsible. Here these things, shielding effect, factor number shielding effect 2 is responsible. Okay. All thing using you will explain ionization energy. You need to now second topics. Effective nuclear charge means positive charge. If nuclear charge increases, ionization energy increases. Like lithium and beryllium, ionization energy increases because this thing, nuclear charge increases. Size of the atom. Ionization energy is inverse proportional to the size. If size increases, ionization energy decreases. Charge. Ionization energy charge, the positive charge is more ionization energy. More positive charge, negative charge, less ionization energy. Okay, this is the positive charge, lithium, and so one positive charge, so lithium is more ion. Here is a helium is more positive charge. Magnesium plus, magnesium 2 plus, magnesium more positive charge, so magnesium 2 plus. Negative charge is inverse, is more negative charge, less ionization energy. Okay. Electronic configuration, more stable is the electronic configuration is higher energy, higher will be ionization energy. So nitrogen and oxygen, which one is more stable electronic configuration? Nitrogen, 2s to 2p3 half filled, and here oxygen 2s to 2p4, it is not half filled or full filled. So nitrogen and oxygen, nitrogen is more higher ionization energy. And then penetration effect, s orbital, p orbital, the order of force of attraction exactly by the nucleus on various subshell is spdf. Thus the easier to remove an electron from a singly occupied p orbital is compared to s orbital. So p orbital, it is attraction, force of attraction is more its s orbital than p orbital than t. So attraction force is p is more than s. So no, s is more than p. So from p orbital, if electron is removed easy, then s orbital. So ionization energy decreases. Okay, this is element. This is which element? Hydrogen. This is hydrogen. This is lithium. Oh, helium, lithium. Then, sorry, beryllium, boron, carbon. This is nitrogen, oxygen, fluorine. Then neon. It is increases. Sorry, okay, this log ionization, I guess. Okay, today's class is now. I'm going to unit 3.